Greetings, Spartan fans. This video is going to cover sections 8.2 and 8.3, law of sines and cosines. Before we start, make sure you have your calculator and make sure you are in degrees. And a disclaimer, no triangles are drawn to size. Mine are not going to be all that great. So just want to let you know that ahead of time. Okay, so the law of sines and the law of cosines. First, let's go back to the 5 ways to prove triangle congruency in no particular order. HL, SAS, SSS, AAS, AAS, and ASA. Note that side-side angle is not a method of proving triangle congruency. So that's ASS, angle side-side. Ass backwards. Nope. HL, if I want to solve a triangle involving hypotenuse leg, if a triangle has a hypotenuse, it must be a right triangle. So you are going to use SOHCAHTOA to solve. Angle, angle, side, and angle, side, angle. If you know 2 angles, don't you automatically know the third? So we are going to use the law of sines, and I'll explain this a little bit further in a minute. And SAS, SSS, we are going to use the law of cosines. Okay. Just going to write it all out and we'll explain. So the law of sines, hopefully you remember this from last year, says that the sine of some angle alpha divided by the length of its side, which is A, is equal to the sine of some angle beta divided by the length of its side is equal to the sine of angle gamma. I'm really bad at drawing gammas over length of its side, C. And of course, from geometry, there's all kinds of proportions that are true. You could say that the sine of alpha over the sine of beta is equal to A over B. You could say that, that A over sine alpha is equal to B over sine beta. So there's all kinds of true proportions from geometry. As long as you know an angle and an opposite side, you must know an angle and its opposite side. And from there, you must know either one side or one angle, a different side and a different angle. So you might be thinking, well, wait a minute. If I know an angle and an opposite side, and then another side, isn't that angle side side, which you just said doesn't exist? We'll get there. Okay, law of cosines is a bit more intense. The law of cosines is a bit more intense. So let me write this down. This is the law of sines. The law of cosines. The law of cosines says that a squared is equal to b squared plus c squared minus 2bc cosine of alpha. Subtraction, don't forget the 2, and make sure that when you plug into your calculator that you're using cosine and not sine. So there are several variations of this. There's b squared equals a squared plus c squared minus 2ac cosine beta, so on and so forth. Okay, so let's just look at an example of solving using both of these. And how do you know which one to use? Well, you could look up here and use that as a reference, or When I set up the triangle, I think it'll be a little bit more obvious. So I'm just going to draw some triangle, not drawn to scale. So one angle might look bigger than the other, very possible. I just draw my generic ABC. Okay, if you are asked to solve the triangle that finds all, that means find all side lengths and find all angle measures. Solving a triangle means find all side lengths and all angle measures. The directions will say how to round. Generally, we round to the nearest tenth. If the directions don't say, then you can round however you want. Just make sure that you round appropriately. For all the examples that I'm going to do, we're going to round to the nearest tenth. Okay. So here we go. Let's say that the measure of angle A that you were given, alpha, measure of angle A, same thing. Let's say that is 48 degrees. Don't forget your degree symbols. And let's say that the measure of angle B is, how about 53 degrees? And let's say that side A is 11. Well, technically, you know all three angles. Use your calculator so you don't make a careless mistake. So the measure of angle C, geometry, measure of angle C, which is the same thing as saying gamma. You don't need to say the measure of angle gamma. Gamma automatically represents an angle measure. This is going to be 180. You do not need to show this step. And this is going to be 180 minus 48 minus 53, 79 degrees. Must be 79 degrees. Three angles in a triangle add up to 180. So now it doesn't matter if I find side B or side C, but I'm going to use the law of sines because I know all the angles. I know an opposite side, so I can set up my ratio as the sine of 48 over 11 is equal to the sine of 53 over B. Do not round until the very last step. Do not round until the very last step. This is going to be 11 times the sine of 53 divided by the sine of 48. I got 11.8. Don't use the 11.8. Stick with the sine of 48 degrees over 11 because that was given to you. And that's going to equal to the sine of 79 over C. So 11 times the sine of 79 divided by the sine of 48, 14.5. Okay, let's do a quick check from geometry. First of all the sum of two sides must be greater than the third. So 14.5 plus 11 is greater than 11.8, 11, 11.8, add together, it's greater than 14.5, etc. And then also from geometry, the smallest angle is opposite the shortest side. And the largest angle, 79, is with the longest side, 14.5. It's a great little check. So you have just solved the triangle. I have a request. Either triangle, just label all of it on the triangle so that when I grade, I can just see it and do a quick check. Or maybe just, at the bottom of your work, gamma is 79. B, and you can just use equal signs at this point. I'm not going to take off if you don't use approximately. Or if you could just label, and circle your answer, it makes my grading life a lot easier. So that's the law of sines. Let's look at the law of cosines. So for the law of cosines, and I'm going to do an example of side angle side. If you know the formula, law of cosines, law of sines, it's really no big deal. So again, I'm just going to draw a completely inaccurate triangle. Hey, at least I'm using a straight edge. If I was drawing it on the whiteboard, ooh, not so good. I'm boring. I always use A, B, C. If you want to use X, Y, Z, feel free. Whatever floats your boat. Okay, so this time I'm going to tell you that side A is, let's do 7. Measure of angle C, also known as gamma. Let's say that is 35. And let's say that B is, how about 6? Law of sines is so much easier in terms of the plug-in, but let's see why that doesn't work in this case. Sine alpha over A, which is 7, is equal to the sine of beta over 6. Too many unknowns. I have to have 3 of the 4 pieces of the ratio, which is equal to the sine of 35 over C. I have to have at least one complete fraction, and I don't. This is the side angle side case, so I need to use the law of cosines. And if you're not sure about that, write it out like I just did, and hopefully you'll see, oops, I don't have a complete fraction. So I have to solve by finding side C first. So if I want to find side C, that's opposite gamma, and I know gamma. So this is going to be A squared plus B squared minus 2AB cosine C, cosine gamma. I recommend you write it out. You'll make less mistakes. So in the formula for the law of cosines, I only wrote out 2 of them, but if I want to solve for angle, if I want to find side A, I need to know alpha. If I want to find side C, I need to know beta. So in this case, I want to find side C, I need to find gamma. And I'll go back in a minute. What happens if you want to find the angle as opposed to the side length? And we'll get there momentarily. So C squared is equal to 7 squared plus 6 squared minus 2, 7, 6, cosine 35. Okay, be careful. It's subtraction with a 2, and it's the cosine, not the sine. From here, I'm just going to do a straight plug into my calculator. 49 plus 36 minus 2 times 7 times 6 times the cosine. And then, of course, don't forget to square root it. 4.0. I'm glad this happened. Nearest 10th, you need the 0.0 as a placeholder. If I tell you to round to the nearest 10th and you don't have the 0.0, you are going to lose points. And let's just do a quick check. 13 is greater than 4, 10 is greater than 7, 11. Yeah, so it fulfills the triangle inequality theorem. And then from here, I need to find the measure of angle A and the measure of angle B. Could you use the law of sines? You could. Just be careful. Just be careful. So from here, the sine of alpha over 7 is equal to the sine of 35 over 4. Use the number that's in your calculator. So the number isn't really 4. The number is 4.0238, blah, blah, blah. I would store it, and I would use that number when finding alpha, because you could be off by a 10th, and you'll lose points for that as well. So this is going to be 7 times the sine of 35 divided by this. So I get that when I'm plugging it all into my calculator, I get the sine of alpha is 0.99 blah, blah, 7, 8, yada, yada. So now I'm going to do the inverse sine of that answer. You get 86.2. So I'm trying to find the angle measure. So I did the inverse sine of the previous answer, which was the 0.99 whatever. So you get 86.2 alpha. Okay, and then you could subtract from 180. I caution you, be very, very careful. If you made a mistake with the 86.2, so I just caution you to be careful. I'm going to do the law of sines again. And I'm going to say that the sine of 35 over 4, which remember is in my calculator, is equal to the sine of beta over 6. Okay, so this is 6 times the sine of 35 divided by, it's not 4, it's that 4.02 whatever, and then inverse sine of that answer. I got 58.8. So be careful you don't round too soon. I would store this number in my calculator. It was really 4.02383. I just lost it. 4.023832. So you might want to store that. Okay, let's do a quick check. It really is helpful to do that. Largest angle, longest side, smallest angle, shortest side. Okay. What happens when you want to solve for an angle? And then we're going to get to the ambiguous case. So for these first two examples, it was pretty much just a plug-in. What happens when you have 3 sides and you want to use the law and you need to use the law of cosine? Okay. ABC, because we're so creative. So let's say I give you A is, how about 10, B is 5, and C needs to be less than 15. How about 12? Let's do a quick check. 22, more than 5, 15, more than 12, 17, more than 10. Okay. I certainly can't use the law of sines because I have no angle measures. Okay, I'm going to find alpha first. 2 ways you can do this. If you are confident in your algebra skills, go for it. If you're confident in your algebra skills, I would just plug in, I'm going to find alpha first. And I would say that a squared, sorry, let me write it out first. A squared equals b squared plus c squared minus 2bc cosine alpha. You certainly don't have to. I recommend it. Why did I? Because I chose to start with alpha first. I could have started with beta. I could have started with gamma. I just chose to start with alpha. And so if I want to solve for alpha, I need to use the formula that involves alpha, angle A, or sorry, side A, opposite angle alpha. Here's where I start. So I could just do a quick plug-in, but I will tell you that unless you have solid, not solid algebra skills, but unless you're careful, you are going to make careless mistakes. You're going to get one of the angles wrong, and then you're going to get the other angles wrong, and it's not pretty. Great. So I'm going to show some work here. So you're going to get 100 equals 25 plus 144. 169 minus, let's see, I'm making the video by myself. I'm going to use my calculator just to make sure I don't make a careless mistake. 120 cosine alpha. These are not like terms. These are not like terms. I cannot tell you how many times I see that this is 49 cosine alpha. No, 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 no. Subtract 169, excuse me. So you get negative 69 equals negative 120. You do not need to show all these steps. Again, for the purpose of the video, I'm hoping that you're going to see, oh, this is where the mistake comes in. This is the same thing when I'm trying to solve as the inverse cosine of 69 over 120. You're trying to find the measure of the angle. This represents the side length. So my calculator, second cosine of 69 divided by 120, which is 54.9 degrees. The problem right here, I see oftentimes that 169 minus 120, this does not equal 149 cosine theta. And if you think it does, then okay, so alpha is 54.9. So for the sake of time of the video, I would plug in, I would use the law of sines, and I would figure out what beta and gamma are. Okay, I'm going to show you how to solve to find the formula for angle alpha or beta or gamma without having to plug in this way. It's some great trig practice. So I guess I'll just do it on another sheet of paper. It's more formulas. Would I memorize them? Nope. I would for sure just make sure that my algebra skills were good. And I would just use the straight law of cosines, and I would use my algebra, and I would solve for x, which in this case is cosine alpha, and then I would use the inverse. However, for fun, because math is fun, how do I solve for alpha? Subtract b squared and c squared. Divide by negative 2bc. Again, I'm trying to solve for alpha, beta, gamma, whatever. Don't like the negative in the denominator, so I'm going to divide everything by -1. Divide everything by -1, and that gives you b squared plus c squared minus a squared over 2bc. Divide by -1, -2 becomes +2. Positive a squared becomes negative a squared. Negative b squared, negative c squared become positive p squared, positive c squared. From here, alpha is equal to the inverse cosine of b squared plus c squared minus a squared over. I will use this formula oftentimes. So for beta, it's going to be the inverse cosine of beta, a squared plus c squared minus b squared over 2ac. Of course, I can do it quickly. I've been doing it forever. And then gamma follows along. You don't have to use these, but in the notes, I tend to use the whatever the angle formulas as opposed to the side formulas. So let's have a conversation about the ask case. It's ambiguous. Ambiguous means unclear. And if you're looking for a picture explanation, I would look on page 526. So if you're looking for a picture explanation, I would look at page 526. I don't do that. I don't know. Sorry. We all know by now that the pictures are not my strong suit, but your book provides good ones. Let's review. I have, let's do that. The opposite side is 0.26. Hypotenuse is 1. This is on the unit circle because the radius is 1. In the second quadrant, we also have some angle with a sine of 0.26. Okay, well, your calculator, when you do the inverse sine of 0.26, so the inverse sine of 0.26, and the calculator says 15.1 degrees approximately. So I'm going to round just for the sake of the video. So 15.1. Great. But there is another angle that has a sine of 0.26. And that other angle that has a sine of 0.26 is in the second quadrant. And it has a reference angle of 15.1 degrees. Your calculator only gives you the first quadrant answer. Your calculator only gives you the first quadrant answer. So the measure the angle in the second quadrant is 180 minus 15.1, which is 164.9. The measure of the angle in quadrant 2 is 164.9. And if you watch, it's going to be a little bit off because I rounded. But if you do the sine of 15.1, oops, sorry about that. The sine of 15.1 is, there you go, approximately 0.26. And if you do the sine of 164.9, you also get 0.26-ish. Notice that they're exactly the same. So there are two angles that have a sine of 0.26. So let's keep that in mind as I'm doing the next example. So again, let's draw. And I am going to use an example from the book. Let's do, maybe I won't do an example from the book. All right, so I'm going to give you the ask case, and this is why you cannot prove triangle congruency. Because with the ask case, you can have one triangle, two triangles, or you can actually have no triangle, and it is based on the side lengths. Okay. So I'm sure it's a big shocker that I'm going to use ABC. Okay. So I'm going to give you an angle. How about, let's do 40 degrees. So angle, side, how about 9? Side, how about, we'll use 6 again. So this is the angle side case. So you're going clockwise, the angle that you hit, then you hit a side, then you hit a side. If the 6 were side B, if the 6 were instead side B, I'm trying to find my pencil here. That would be side, angle, side. So what I do, as soon as I see this, I put a big star. Because what will happen is if you forget, if you miss it and there are two triangles and you only solve for one, you're going to lose 10 points off the bat. So be really careful, make a note to yourself. Well, when I start with the sine of 40 degrees over 6, well, perfect. I have a fraction. I have an entire fraction. Awesome. I'm going to be able to solve. And that's going to equal to the sine of gamma over 9. Okay, so this is going to end up being that the sine of gamma, solve on your calculator, 9 times the sine of 40, 9 times divided by 6, and you get 0.96-ish. Okay? 0.96. Awesome. So I am going to draw the little quadrant that I did up here. So that means the sign is 0.96 in quadrant 1, but could also be 0.96 in quadrant 2. So how do you know? Well, let's do a quick check. So let's do inverse sine of 0.96. So I'm going to do inverse sine of that answer I just got above, which was 74.6. So this is for sure 74.6. What I just saw for gamma. For sure. The question is there another triangle? Well, how do you know? So if it's 74.6, that is my reference angle in the first quadrant. But it could also be 74.6 in the second quadrant. So the reference angle could be 74.6 in the second quadrant, which is what I did up here. I said it was 15.1 in quadrant 1 or 15.1 in quadrant 2, but the measure of that whole angle was 180 minus 15.1. So the measure of this whole angle is 180 minus 74.6, which is 105. So the quadrant 2 angle would be 105.4. Okay, so I'm not going to draw my triangle to scale. I gave you A, B, C, and I gave you that angle A was 40. I gave you C was 9, and I gave you A was 6. This is what the given was. And we figured out that it was 74.6. While the other option is 105.4. Again, totally not drawn to scale, as you'll see in the next 10 seconds. So angle C, gamma, could also be 105.4. Is that doable? And the answer is yes, it fits. 105.4 fits because 40 plus 105.4 is less than 180. 40 plus 105.4 is less than 180. So it fits. This is two triangles. So now I have to find beta for both of them, and I have to find side B for both of them. It's two triangles. Okay. To find beta, you could do, actually you have no choice. You need to subtract from 180. Be careful with your rounding. Be careful with the rounding. So this wasn't really 74.6. It was 74.6185, blah, blah, blah. And it wasn't 105.4. It was 105.38143117. So you might want to store those in your calculator, or if you're savvy, just use your up arrow keys to highlight, whatever works, but be careful with the rounding error. So I'm going to do the 105.4 just because I'm here. So I'm going to do 180 minus 40 minus that answer I just got, and it's 34.6. I found beta by just subtracting from 180. So again, where did the 105.4 come from? 74.6 first quadrant, reference is 74.6 second quadrant for a total of, it's not, the whole angle isn't 74.6. The whole angle is 105.4. And now I can find side B. So side B is going to be, I'm going to use the sine of 40 over 6. And that's going to equal to the sine of 34.6, which is in my calculator. And that's going to be over B. That's a B. 34.6 is in my calculator. So 6 times the sine of 34.61 blah blah divided by the sine of 40 at 5.3. Okay, so up here I'm going to do 180 minus 40 minus that 74.6, which for me is way up here somewhere. Here it is. 65.4. Yes, I mean, it would have worked had I not used exactly 74.6, but I'm not taking any chances that I'm going to lose points. Half points, half points, half points add up to a lot of points. The sine of 40 over 6 is equal to the sine of 65.4 over b. 6 times the sine of that answer I just got divided by the sine of 40, 8.5. Let's do a quick check. I didn't check the other one. 74 is the largest, 9 is the largest. Boom, boom. Okay, this works. It's always good to do a quick check. 105, 9. Yep, we're good. That is the ambiguous case. Really quickly, if you've forgotten how to store in your calculator, whatever, I have some number, and I want to store it. STO key at the bottom, and choose where you want to put it. Whatever, alpha, which is underneath second, and choose a letter. So if you choose number 9, it's going to be stored in spot Q. And then to recall, just type in alpha Q, and there it is. That, my Spartan fans, is basic law of sines and cosines.